Thank you so much for having me. So last semester I was talking to Nick and we were talking about my course and he said, why have you never presented at the Teaching Innovations Conference? And I like, oh, because it's not innovative. We've been doing this for 20 years like this. And he said, no, but people on campus don't know about this and I should talk about it. So here I am and I'm going to tell you how we're handling the engineering physics. What I'm going to talk about is what are our goals for our large enrollment classes, what components make up our course, how do we achieve uniformity across these sections, how do we handle the homework and the exams, what resources we provide to our students, and what disadvantages are there. And I'm sure I can provide you the slides, so if anybody wants to, I'll just send you they can forward you the presentation. So, our large enrollment, what numbers are we talking about? Here is our enrollment in Physics 1135, Engineering Physics 1, over 7 semesters. And depending on semester, it varies a little bit. We're talking around 500 students, sometimes closer to 600. So typically between 1,000 and 1,100 students a year. So, and our goals for teaching this class we want to create a comparable learning experience for all students across the sections. That means they should get exactly the same material, should have the same assessments, and should be held exactly to the same standards. That is very important to us. We want to make sure that we find a way to incorporate active learning in our problem solving and discussion sections, because as you all know, nobody learns physics from watching somebody do physics. It's not a spectator sport. We want them to have individual attention from their instructors, which means that we have to incorporate a component that has smaller class sizes, and that will be our recitations, which are our discussion and problem solving sessions. We want an experiential component where they actually do something hands-on. That would be our labs. And we are encouraging them to take advantage of peer teaching, which mostly takes place in our Physics Learning Center. That is our name for our lead sessions, which constitute almost the hard piece of this course. So it's a 4-credit hour course and it has 3 different components. There are lectures, there are recitations, there are labs, and I'm going to tell you a little bit about what each of those components is doing. So let me talk a little bit about the lectures. There are 2 lectures per week for all the students, and we offer 2 live lecture sections that are in the classroom. Our physics classroom seats 140 students. We have to teach the lectures in that classroom because I'm doing demonstrations, so I can't just go over to McNutt and bring everything here, so it's got to be in the physics building. And in addition to that, we offer an asynchronous online lecture section, which holds, well, anybody who doesn't fit in the seats in the live lecture section. All the lectures in the course are taught by the same person, and they're identical. So I give 2 back-to-back lectures in the lecture hall, and the content of the online lecture is the same. The format is different, so I'm not presenting a videotaped 50-minute lecture where they watch me in the classroom. The online lectures are produced specifically for the online format, so instead of them seeing a video of me working on the blackboard, they see the tablet screen, they see the writing appear, they see their problems develop. But we cover exactly the same examples, the same slides, the same content, so that students who might have to miss a presence class, they can go and watch the video and get the same material. I'm the course coordinator and lecturer for the Physics 1, and my colleague Jim Musser, who is Associate Teaching Professor in Physics, is the course coordinator for Physics 2135, that's the Engineering Physics 2, and the formats of those 2 courses are comparable. So in the lectures, we're summarizing the most important points from the assigned reading, going over the basic concepts, modeling, problem solving, and we're doing demonstrations. The second component of our course is a recitation, problem solving, and discussion section, and students have 2 recitations each week. And the recitations are sizes of about 35 students, And that means that we have to run between 12 and 17 recitation sections. And they're all classroom-based. So even the students who have the asynchronous online lecture will attend a in-seat recitation. And what is special to our department is that we have all recitations taught by faculty. And I'll talk a little bit about that later, what the advantage is. So some semesters we get by with course coordinator plus 4 recitation instructors. Some semesters we have a lot of enrollment, and it takes 7 recitation instructors to cover all the classes. So that varies a little bit from semester to semester. And in the recitations, that's when we do the problem solving, go over the homework, and tell you a little bit more special thing that we're doing in those recitations in a moment. For the labs happen every other week. And we have about 20, upwards of 20 sections. They're all live lab sections in an actual lab. So we're not doing it like chemistry, where they send the students with a lab kit home and they do half the lab with the kit from the library. Our students are actually in the physics lab. And our labs, that is the only class that in our department is taught by graduate TAs. All the other classes are taught by faculty. And we're trying to match the lab schedule to the material that is covered in the lecture so that there is the tie-in. It doesn't always work perfectly, but at least it's supposed to match the content of what they're just covering or just have covered in the other components of the class. Some issues that are crucial in the large enrollment classes, how do you hold them accountable? So, and how do we unify the course? So I said at the beginning, we want to provide the same experience for all the students. And so it is very important to us that we unify the course across the components. So we're teaching identical lectures to all students that are taught by the same instructor, so that person knows exactly what they said in each of the sections and can make sure that that is really uniform. All our students have identical homework assignments, and the course coordinator is the person who writes those homework assignments. In the recitation, the students work on practice worksheets that have part are some multiple choice practice questions from old exams, and there's a work problem for problem solving that's also usually an old exam question. We're using the same worksheet across all recitation sections. Course coordinator is the person who makes the worksheets. Our students are taking the identical exam. We give common exams. We design the exam as a team, and all our students take the same exam. And all the sections have the same syllabus. We have the same point structure, we have the same grade cuts, and we have the same rules. So the only variable is who you have as a recitation instructor. But we do not want the students' grade or experience depend on what recitation section number they happen to end up in. So with the large number of students, one question is, of course, what do we do about the homework? 500 students that have 2 assignments per week and 4 problems per assignment, they produce 4,000 homework problems per week. So the solutions are coming, and there is no way to have a human grade that much homework. Also, if we had humans that could grade that much homework, we would reward copying, because then you'd give an incentive for students to just copy the homework from their classmates or from the solution manual that they'll find online. So we got to have something better. Now the big question is that's what the publishers want to push, automated grading system, mastering physics, Pearson. Is that the solution? We tried out something like this for a couple of semesters. We come to the conclusion it is not the solution for a variety of reasons. First of all, there's additional cost for the student, which I object to on an ethical level. We shouldn't nickel and dime them for more and more stuff. They're already paying enough tuition. The systems are stupid. They can only evaluate the final answer, but they cannot evaluate the process. So if they just budget so that one of the students, they make teams, and they pick a sacrificial lamb, and they try, and the sacrificial lamb tries, and if they happen to get the right number, then they're all using that formula. So, and the semesters we tried that, we saw it encourages sloppy work because they're no longer writing a good solution, making a diagram, following the procedure. They're just fudging it until the system says green check mark. So we need a better solution, and for us, the solution is board work, which we've been doing for, I think, when I came here 18 years ago, we already did it this way. And so far, none of the colleagues has suggested a better system. So what's board work? In the recitation, we call our students to the board at random to present one of their homework problems without their notes for a grade. So the way this works is the recitation instructor either picks up front or throws the dice or does the random pick from the class list, picks 5 victims or 4. They get a copy of the problem. They get a copy of our official equation sheet. And then they get to go on the blackboard and have 20 minutes, 25 minutes while the rest of the class is busy with the worksheets, and they have to work out the homework problem that was due that day that they were supposed to prep. And that is a pretty good carrot to get them to actually do the homework. It has 2 big advantages. First of all, copying doesn't help you, because if you copy it right before class, there's no way you can reproduce it 10 minutes later on the board. The second thing that I really like is, as an instructor, you get to walk around and you get to see how they're doing, and there could be a situation that there's a student who's stuck like 2 lines in. Now you can see, maybe if I give the student a teeny tiny hint, does it get them unstuck? Can they show me they can do the rest of the problem? If they can, I can choose to just take off a little bit of the points and see they know 90% of the stuff, they just didn't know this little bit. Or you can ask a student to narrate their solution and talk about it. So you get a much better understanding of the student's ability by seeing them work the problem on the board and dialoguing about that. So this is what we're doing to hold them accountable for homework. We still pick up at random times a paper homework 6 times throughout the semester and grade that, but that is the biggest incentive for the students to actually do the work. The other issue with large volume of assignment is what you do about 500 exams. So we give our common exams from 5 to 6 on Wednesdays. That is the time slot the university has reserved for common exams, and if a student has a common exam during the time, any class or lab or whatever they have a conflict with, that instructor needs to make arrangements so that the student can participate in the common exam. We're spread out 7 or 8 rooms across campus. Students with disabilities who need extra time start early so that everybody gets finished at 6 o'clock. And then the fun begins. We are gathering in the conference room in physics at 6:15, and we grade. And we grade. And we grade until the last test is graded. This is how we do this. We have the recitation instructors and the course coordinator, me, and our lab TAs and our 2 undergraduate graders, and then we holler for help and say, here, if you're lead PLA for our course, would you like to volunteer? We feed you pizza. Come help grade. Believe it or not, there's always 1 or 2 takers, which is awesome. So we do this assembly line style. We make teams. We have 3 fully worked out problems and a page of multiple choice, which gets graded last. So we make teams, 3 to 5 people, and each team grades the same question all night, and they have a grading rubric, and they follow that rubric. And that way, we assure uniformity for the grading, and the advantage of doing it all with everybody present is, now I can write a grading rubric saying, let's take 3 points off if they have a cosine instead of a sine, and let's take 2 points off instead of a minus where there should be a plus. The grad students and the graders, they can figure that out. But then you have those papers where this is all over the place. It's a bunch of gibberish, and you have to handpick and try to figure out what that person is doing. If we're doing it in the team, the helper students, the assistant graders, they are told, if you can't figure it out, hand it to the faculty member, grab the next paper. So typically it ends up with the professors grading really crummy papers all night and the grad students taking care of the ones where you just 3 points here, 2 points there, boom, done. So we do this, and then the grades are posted the next day at noon, and the tests are returned Friday in recitation, and the students love it. The students like the fast turnaround because one of the 7 principles of education, the prompt feedback. They want their prompt feedback. They want to put that behind them and then move on to the next thing. What resources do we provide for the students to be successful? Well, first of all, I provide all the resources for the course through my course website. And there they find all the lectures, even all the videos for the lectures. So any student in the live sessions is able to watch those videos. I've just put a screenshot here of what one lecture page looks like. So this is lecture 4, and they'll find lecture notes in PowerPoint and PDF. They find all the videos of the lecture and have them broken down in such a way that they can easily also go back and say, hey, I just wanted to look at that example again. Here is the example. Or I really want to see her shoot Barney one more time. So you can watch me shoot Barney again. And you can go and watch me shoot Barney if you want to do that. And I've also put a bunch of extra examples on there so that they have more examples that they can work through with me in video form. Now, our turnaround time for the homework is fairly quick. So I have a lecture on Tuesday, homework's due on Wednesday. Next lecture is Thursday, homework's due on Friday. And for the Physics 2, it's a similar system, lectures Monday, Wednesday, homework due Tuesday, Friday. So what we do is instead of doing office hours, which for 500 students is really not a smart thing to do, we open 2 classrooms in the physics building, room 129 and 130. They have a connecting door, so it's very convenient. And for 5 hours on the days when they have to work their homework, we're staffing those rooms with lead PLAs and with faculty, and the students can come in and do their homework there, work in the group, bring their friends, eat their snacks because they don't have time to have dinner. Come sometimes with the worked out solution already, say, hey, I just wanted to check this problem. They can do that. And it's not mandatory. They don't have to be there at the beginning, but they can come at any time. In the past semesters, when I did surveys, it turned out that about 50% of our students have used the PLC at one time or other during the semester. That doesn't mean that 50% of the students are regular attendees, so that number is smaller. But it's a resource that is appreciated. And once they figure out that this is what you do in Physics 2, they have it real easy because I trained the students already, so they know that if you want to do well, just come to PLC. Physics 2, the first Monday of the first week of classes, their PLC is packed because they all remember from the last semester. Advantages for our department. Why do we throw that much manpower at this problem? It binds a lot of faculty, and we have at the moment about 75% of the faculty members at least one semester in the year teach a recitation. The biggest advantage of that is that everybody has skin in the game. So for our department, we're a small department and we have only about 80 to 100 majors. The majority of our teaching is the service teaching for the engineers. That's our biggest task here on this campus. And having the majority of the faculty involved in that in one way or the other means that you have to be invested and that you can't say, oh, it's this person who's in charge of the engineering physics and I just want to teach my upper level physics class and I don't care what they do. They all have to care and they all have to know what is going on, and I think that makes that is good for the department and for the course because people are more invested in this important part of our educational mission. What's also good is that you get the different perspectives, especially when we do this collaborative test creating. Would it be faster if I wrote the exam myself? Oh, absolutely. So it's not faster to have everybody contribute. It takes a lot more time. But first of all, you have the buy-in. So everybody is involved in the test creation. So if the exam average comes out low, they can't say, Agnes wrote a bad exam. We all wrote the exam together. And that also prevents us from falling into a rut, because if the same person writes the exam over and over again, it's always end up with the same type of question. So having some fresh ideas injected, that's a good thing. Now, however, that rigid structure isn't appreciated by everybody. So you have little flexibility as the recitation instructor, and so there may be faculty who are really happy with the structure and would like to change things if they were in charge. And over the 18 years I've been here, there have always occasionally been a person who's had some grumbles. But that unhappiness never rose to the level of somebody actually wanting to take over the course. So they're all perfectly fine just doing it and occasionally complaining a little bit. One issue that we're having in this course is that we see a performance difference between the in-seat and the online lectures. And if I want to take a couple minutes to show you that and talk a little bit about that. So when we're looking at the final grades in Engineering Physics 1, we see that in every single semester, the students who are in the in-seat section, that's here in blue, have a higher grade than the students in the online section. And the difference is about half a letter grade. And that is consistent through the performance in every single exam. So yes?
Is that the grade in this course or just their overall?
That is the grade in physics. This is the GPA in physics 1135. So we're just taking their number grade and we're averaging across all the students in a given section. So each point is like the average of like 300 people. So we see this on every single test, on every single exam over those 7 semesters where we ran the data. The students in the in-seat session perform better than the students in the online. And Jim Musser and I, we applied for an education research mini-grant to investigate why that is, because one of our things that we want to find out is, before we think about whether it's the teaching, let's look at the demographics of the students who are in the online sections and who are in the in-seat sections. And the hypothesis which I went into that project is that I have a hunch that the students who are least well positioned to succeed in an online class are more likely to sign up for the online class. And the students, the better students, they're more likely to sign up for the in-seat class. So we have used the funds from that grant to pay a statistics grad student to analyze our data, and we're working with Gayla Albrecht in stats, and we have some preliminary data that from the first glance it looks like, yeah, the people with the weaker math skills tend to have a higher probability of being in the online section than in the in-seat section. So we're doing some more analysis, and we will present this outcome. It's rather interesting because before we blame it on the online format, we would like to know whether the composition of the students is different. Okay, I want to stop here and see if anybody has questions before I turn it over to Scott. Yes?
Yeah, I want to make reference to your exams. And this has been an eye-opening presentation for me, because I kind of lead the GTAs on a large class of about 150 students. And we see this kind of experiences coming up. And I'm glad that it's not unique to us. So my question is, do you pull your exam questions over the years and draw from them, being that some of those questions may have come from different types of faculty?
Well, our typical test structure is a page of multiple choice and 3 fully worked out problems. And we are archiving all our exams over the past years. So when a professor submits a question for the new exam, then it is possible that they have drawn on that archive. And in fact, I encourage them to use the archive and modify the problems, because you know what a pain it is to draw those figures and stuff. So what we never do is we never give the identical exam twice. But there are some problems that we may have given years ago that one of the problems might be an older exam question. But there's always some new ones, yeah.
In the study, are you guys also looking at when the students sign up for the class? Because I would think the NC one fills up first, and students who wait and postpone and sign up later get the online one.
That's what I thought, and that was the case in 2014. So the first semesters, the NCs were full really quickly, and then the online filled up. Over the past couple of years, my NCs aren't full. For some reason, students think 9 o'clock is an ungodly time, and we cannot possibly be expected to go to 9 o'clock class. So I have 50 empty seats in my 9 o'clock. So that was one of the variables we pulled to see their sign-up window, whether they sign up on the date that their appointment is, or whether they wait till the last minute, because that would indicate a student who's really not on top of their game. But since there are still seats open in the in-seat, even now, that doesn't seem to be. But I had thought of that, but it doesn't seem to matter. Any other questions?
Do you keep attendance in PLC?
No, we do not keep attendance in the PLC, and it has been. You probably remember Ron Bienick, who was my predecessor, and he tried that and giving extra points. I am opposed to that because the PLC is not during regular class times, and I do not feel I should be rewarding students who just happen to have a schedule that allows them to come to the PLC, because that penalizes people who have classes or have to work a job. So no, that's why I don't reward PLC, not even with bonus points or anything, because I don't think that's fair. Any other? Yes?
So how do you then motivate students to use the PLC? Because we have such a session that comes out empty for the first 4 weeks. And then when we're approaching lab exams, everybody's rushing in to try and do something.
I give them hard homework. No, seriously, because the first day it's empty, and then they have the first assignment, they say, okay, still okay. Then they get the second homework assignment, and then either they realize, oh, I have no clue what to do, or they think, oh, yeah, sure, I can do that. And then they come to the recitation and they realize, oh, I was deluded. I couldn't do it. So it picks up because they found that the problems are hard. And it varies from semester to semester. Some semester is poorly attended and they bum the first exam, and the day after the first exam, they're there. But basically it's, they're held accountable for the homework. They see the homework is hard. They come for the help, and we make it a welcoming environment. And I also announce in every single lecture at the end, I announce the PLC times and remind them that they should come to the Learning Center and tell them what the times are. So, but it's word of mouth. They hear from other students that it works. The recitation instructors encourage the students in the recitation. I encourage them in the lecture, and then it's just, yeah, you got to be able to do the homework the next day. So I think that does most of the trick.
Do you encourage more than one PLC time? Because we have one lead time that is pretty.
Well, we have 5 hours, 2 to 4:30 and 6 to 8:30 twice a week. So we have a total of 10 hours a week. And the students don't need to be there for 5 hours. So typically the assignment is designed, I would say, for them to take about 3 to 4 hours, and the harder assignments, if they're really good students, they get done within an hour and a half. But more like 2 to 3 hours is realistic when they're just learning. So they come for one session, don't quite get done, come back, or they start ahead and come and finish it. So that's what we offer those times.